So I just give you guys 5 random problems of factoring, and I'm going to go over the last 2. So here, the first thing I'm going to do always is GCF. Everyone say GCF? Yeah. I'm always going to look for the greatest common factor to break down the problem with smaller. I'll show you what happens if you don't do that. I'll still do the problem. So I can break it up into factors and figure out the greatest common factor. Now this 20, I'm not going to choose 2 times 10, I'm going to choose the 5. So that would be 5 times what? 4. They have a 5 in common. This is now your greatest common factor. And we look at what we did not circle in red. That is x squared minus 4. A lot of students will actually stop there. This will be a 3 out of 4 because you have to look here. Here you have a binomial 1, 2, and there's a special case for that which we're going to practice today and tomorrow, but I don't want you guys to memorize there's 2 extra formulas. It's just not worth it. So there, you should recognize that you can put a placeholder in there. And I'm highlighting now the inside the parentheses because that's what you're going to do your X box with. A, B, and C. So A times C is -4. B value is 0. 2 numbers that multiply to be -4 but add to be 0. 2 and a -2. Remember, if you need a hint, here's a good strategy. Regardless if this is positive or negative, just write out all the factors. And I like to write out the factors where the larger number is on the left side. So for example, 4 times 1. And the reason why you want to do that is because if that number is 3, then I would choose a combination of positive and negative 4s and 1s. Or you can also do 2 and 2. So it gives you a nice visual of what to do. Because your A value is equal to 1, you only need to do the X. If you don't understand when to use the X in the box, I would just suggest to keep doing the X in the box. Here you already have your answer, but I will show you just in case you do not understand. You're going to put in x squared, -4. Those in red are splitting the B term, so you're adding an X. And then here we're just looking for the greatest common factor. Greatest common factor in this direction is X. This direction is this direction. And in this direction. So again, notice I could have just gone to my answer by x plus 2, x minus 2, or we already have here in blue. So my answer is 5 times x plus 2, x minus 2. Everyone say difference of squares? They call this the special case is called the difference of squares.
The x plus, that's not considered short work, right?
Yeah, so if you, as long as you're not copying your partner's paper, you can actually just go from here to there.
So we still get the full
You still get full credit. Because some people can do it in their heads. Let me show you what to do if you didn't see the GCF. In this problem, you can still put a placeholder. Do your X box. It's just the numbers are larger and harder to deal with. Factors of 100 are 100 times 1, 25 times 4, 50 and 2, 20 and 5, 10 and 10. Class, what would I pick? But remember now, you have to do the box because you have an A value that's greater than 1. And if you don't understand that, just keep doing the X in the box together. And now I'm just going to take out the greatest common factor and notice how the number is a little bit larger. 5x. This one will just be, can I get away with 2x there? You're right, x. 5x times x is 5x squared. 5x times -2 gives me -10x. This will have to be a positive 10. So x times 10 gives me 10x, and 10 times negative 2 gives me negative 20. So what would I do there? I would have x minus 2, 5x plus 10. Notice how my answers don't match yet. But if I look here, there's a what? A GCF of 5. If 5 comes out, I'm left with x minus 2. And this would be x plus 2. So math is very forgiving. If you forget that first step of the greatest common factor, you can still do the problem, but notice the numbers are larger. For question number 5. Count with me, ready, set, go.
1, 2, 3, 4.
Okay, now I'm making the problems easy. Very difficult factoring by grouping problems, they mix them all up, and then you would have to put them in groups. For our case, you could just look at the first two terms. I put that in pink, yellow, that's yellow, this is pink. And then here you're doing your first GCF, the first set of GCFs. You can write out the factors if you need to. Again, some of you need to do this, some of you do not. It's just a scaffold. Now, I'm going to put a 1 in here, and you'll see why in a second. Class, what's the GCF there?
5.
Okay, look. There's one set of 5s, so you just write 1, 5. And then you have one set of x's, so you put an x. Okay, I'm left with 2x. And the reason why I wrote the 1 there is because if you see nothing left in there, some students just don't write anything, and that would be wrong. You have the 2, and then you have this 1 there. 1 will always be there. Should you always write the 1? No. But for those who are kind of need that scaffolding, you can do that. Now look, this is our hint. If you're feeling confident about what you just did here, look, this is what we should get on the other side, right? So 2 times 2 times x. In this case, I will do 2 times 1. Class, what's the GCF there? 2. What did we not circle in red?
2x
Plus 1. Now for my second GCF, or second set of GCFs, I notice that both of them have the same. Remember, you know you're doing it correctly if these are exactly the same. I'm going to write everything in green here. You're pulling it out. 2x plus 1. You're left with 5x plus 2. How does that work? How would you check your answer? You would take this quantity 2x plus 1 times 5x. Quantity 2x plus 1 times 2. Do you see that? And then this is our answer. Here's a couple, 2 problems of just randomly factoring.